What we have here is a reversing three-phase motor starter. We have a forward contactor, a reverse contactor, overload heater block, control power transformer, fuses, and of course the motor. Over here we've got a push button station, forward, reverse, and stop. So I can demonstrate very quickly how this works. Forward, and the motor's going in the forward direction. Hit the stop button, and the motor stops. Hit the reverse button, and it spins the other direction. What I'd like to demonstrate right now is what happens when a motor single phases. And it's pretty easy to demonstrate this. We can just simply pull the fuse open on one of our three-phase power leads. This happens to be lead L3. L1 and L2 are still connected, and they're still providing power to our control power transformer, but the third fuse has now been disconnected. So if I try to start this thing, the motor is only going to receive 2 out of the 3 phase connections, which will essentially be single phase in the motor, 1 voltage across 2 terminals, and as a result it will not start because induction motors require a rotating magnetic field to get going, and a single phase magnetic field is not really rotating, it just oscillates. So I'll show you what happens. Go ahead and focus the camera over here on this side. I will press the start button and we'll see what happens. It hums but no motion. I hit the reverse button, same thing, it hums but no motion. The forward and reverse is still, both are missing the L3 connection, so nothing works. However, I want to demonstrate an interesting phenomenon. That is, if I give the motor a kickstart mechanically, it will take off and move in whatever direction I wish. So I'll energize it here, again, single phase power. I'll come over here and rotate the shaft this way, and it takes off and runs. Now, I'll push the same button. Single phasing, I'll rotate it this way, takes off in that direction and runs. So a single phased AC motor may continue to run, however it cannot start. It definitely needs that rotation. Now when all 3 phases are connected, such as this right here, I've connected the third phase, now it starts in the proper direction when I hit the different switches, forward and reverse, exactly as it should. But it serves as a good illustration about how a single phase AC induction motor works. With a single phase AC motor, you don't have 3 phases from your power supply, you only have 1 phase. So to get that single phase motor started, you do need an additional phase to create a rotation of the magnetic field. And so many industrial single phase motors have a bulge in the side where a capacitor is held. That capacitor creates a phase shift that powers up an auxiliary starting coil that's out of phase with the main coil, and that produces a 2-phase rotating magnetic field to give a definite rotation. In this case, however, it's a 3-phase motor, and so when all 3 phases are active, it doesn't need any tricks like that, it just takes off and runs. However, as we demonstrated, if we were to lose 1 phase on our 3-phase motor, it refuses to start. It doesn't know which way to go. In fact, spinning in either direction will get it going. It'll take off in whatever direction you wish.